call is now being recorded.
Good morning, students. Welcome to lecture series on digital electronics. Today we are going to discuss about Moore mission model. Okay, I'm P.Logamurthy, AP Assistant Professor ECE, Erode Sengunthar Engineering College. So first, you should know about Moore. What is Moore mission and Mealy mission, and what is the difference between them? Moore mission means, okay, output depends only on present state. Okay, output present on only present state. Not it does not depend on input. Whereas in Mealy machine, the output depends on both the present state and also the input. Okay, and in the second point is the input changes does not affect the output in Moore model because it does not depend the input. Whereas in Mealy machine, the input changes may affect the output, and if there is any glitches, that will also affect the output. And in more model and more number of stages, because we have to use the flip-flop, so more number of stages have to be implemented in this function. Whereas in melee, so we'll have a less number of stages because we do not use that flip-flop stages. So today we are going to see this problem. Construct the transition table, state table, and state diagram for the more sequential circuit given below. Okay, so more model means the output will be represented in the circle itself. Okay, I'll show you in the next slide. Okay, so this is a circuit they are giving. So two flip flops they are using, and they are using the JK flip flop. So JA, KA, JB, KB are the inputs. QA is the output for A flip flop. QB is the output for B flip flop. Okay, so here the x is the input, and this x is so let me say one by one what is JA and what is KA, like that. So JA means just simply B. You see the input comes to JA. So JA comes from, it's like it's coming from B. So JA equal to B, KA equal to x dash. Okay, so this what I have put in the next slide. See, JA equal to B and KA equal to, so we are using on AND gate output to KA. So x dash into B, x dash into B. So this point, this blue point refers the B. So x dash into B is a KA. Similarly, JB equal to x dash. Simply, you just follow the line of JB. So you follow. So x dash. Okay, x is inverted and get, so x dash is the JB. KB means you have x value and x, and see the follow the line. Okay, one input is x and another input is A. Okay, so A XOR x is KB. So this is what I have written, x XOR A. So this is the first step. You have to determine the flip-flop equation and output equation. What is the input for flip-flop and what is the output? That is the first step to solve this problem. They will give you this diagram and construct the transition table and state diagram for the more sequential circuit. These are the input they will give. So you have the first step is you have to obtain the what are the input and what are the output. Okay, flip-flop input and output. Step 2, you have to obtain the transition equation for the JK flip-flop. So already we have discussed in third unit. Okay, in sequential circuit we have discussed about what is maybe transition state. So it has to be obtained from the truth table. Okay, so JA, so this is general form. Okay, J Q dash plus K dash Q. This is general form. Okay, for A flip flop I have written A in suffix. Okay, so and JA means B. JA means B and QA dash. Okay, QA dash means A dash and QA means A. So I have put QA dash means A. Okay, plus KA dash mean KA is already we know KA is x dash B And so x dash b, and we are having ka dash, so I have put one inverter here, one so x dash b bar. QA means A. So this is a general equation, and here you have to, this in this area you have to use the De Morgan's law to break up this variable. So B into A dash plus X double dash, okay, X double dash plus B dash into A. So this is a, and this X double dash becomes X. So the final equation becomes X, B A dash plus X plus B dash into A. So we have to substitute the values. Okay, see, we have to substitute the value. So this is what equation we got. We have to substitute the A equal to 0. So this is a table. From this value, okay, so from this table we have to obtain what is the condition for A equal to 0, B equal to 0, X equal to 0. Okay, now I'm going to calculate the value for this QA plus. So take this equation BA, okay, BA dash plus X plus B dash into A. Okay, this is the equation. In this equation you have to substitute A equal to 0, B equal to 0, X equal to 0. If I substitute this value, B value is 0. Okay, B value is 0. B value is 0. A dash mean 1. A dash mean 1. Plus X value is 0. B dash equal to 1. Because B equal to 0, so B dash equal to 1. Into A equal to 0. So this term becomes 0. Okay, the second term becomes 0. And the first term also becomes 0. So that we'll have 0 plus 1 into 0, which is equal to 0. So we have to substitute the value over here 0. Okay, and the next case we have to substitute x equal to 1. Okay, x equal to 1, so that, okay, so second case is a equal to 0, b equal to 0, and x equal to 1. Okay. In this case, you substitute the value in the first equation. So b into a dash. So b equal to 0, a dash equal to 1. A dash equal to 1. The same case, only the value change is x. Okay. So x value is now 1. B dash equal to 1. Because b equal to 0, so b dash equal to 1. Into a value is equal to 0. Since a equal to 0, so that even though we got 1 here, but a equal to 0, so that the second term becomes 0, first term also becomes 0. So 0 into 1 equal to 0, plus 1. In OR gate, in digital electronics, will 1 plus 1 equal to 1. Okay, 1 into 0, which is equal to 0. Okay, so here also we get the value 0. For the second this case, okay, a equal to 0, a equal to 0, say example a equal to 0 for the this value. Okay, so a equal to 0, and b value equal to 1, b equal to 1, and x equal to 0. So this is the third case you have to substitute. Okay, so what is b? B equal to 1, so 1 into, what is a dash? A dash also 1, plus x equal to, what is x? X equal to 0, plus b dash. B equal to 1, so b dash equal to 0, into a equal to 0. So here we will get 1 into 1 is 1, plus 0 is equal to 1. So I put here the value is 1. Okay, for the next case I will put a x equal to 1. So you can check the value. Okay, x equal to 1 means in this area, the same 1 into 1 plus the only change is x value. So 1 plus 0 into a value is 0. So the total value becomes, this second portion becomes 0, right? So 1 plus 1 equal to 1 plus 1 into 0 equal to 1. Okay, so here also we get the answer 1. And third case, substitute the value a equal to 1, b equal to 0, x equal to 0. So substitute this value here. 2a plus equal to b into a dash. So b into a dash equal to 0. The first portion becomes 0. And x value is 0 plus b dash, b equal to 0, b dash equal to 1 into a value is 1. A value is 1. Therefore, you will get 0 plus 0 plus 0 plus 1 equal to 1 into 1. Therefore, 0 plus 1 equal to 1. So I can put here this value is 1. It's value equal to 1. Okay. Next one is a equal to, so you can change this value alone. Okay, so x equal to 1, the same case, a equal to 1, b equal to 0, the value only change is x value. So you will be getting 0 dot 0, 0 into 0 plus x value is 1 plus 1 into 1. Okay, so this will be the value, and so we'll be getting the value. The answer is 0 plus 1 into 1 is equal to 1. So here also I will get 1. Okay, so in this case, for the case a equal to 1, b equal to 1, and x equal to 0, we substitute this value. Okay, substitute a equal to 1, b equal to 1, and x equal to 0. Okay, substitute this value in the equation. Okay, b into a dash, b equal to 1, b equal to 1 into a dash equal to 0. So first portion becomes 0, and x value is 0, b dash equal to 0. Okay, b equal to 1 means b dash equal to 0, and a value is 1. A value is 1. So what is the value? 1 into 0 is 0. 1 into 0 is 0. Plus 0 plus 0 equal to 0. 0 into 1 equal to 0 into 1. So it is equal to 0 plus 0 equal to 0. Okay. So I can put in this case here the value. The 110 is 0. Okay. Next case, both all are 1. Okay. For example, a equal to 1, b equal to 1, x equal to 1. Okay, so in this case we are having all are 1. So you can put the value is b equal to 1 into a dash equal to 0, x value equal to 1, b dash value equal to 0, into a value equal to 1. So what is the value? 1 into 0 is 0, plus 1 plus 1 equal to 1 plus 0 equal to 1 into 1 is equal to 0 plus 1. Okay, so 0 plus 1 equal to 1. So here I have got a value 1. Okay, so this value we are going to convert into these values into state table. Okay, A and B values are here, and the x value equal to 0 and x value equal to 1. Okay, so this value will be converted here. Okay, see that table. We come to the, let's see the PPT. Okay, so this is the first step, and second step we obtain the expressions. Okay, we obtain this expression and we substitute the value. Okay, we substitute the values. Okay, we substitute the value and we finally we got this answer. Okay, we obtain no 0 0 1 1 1 1 and 0 1. This is the value of qa plus. Qa plus means next state. Okay, and next step is step 2 is qb plus. Okay, because we are using two flip flop, no, so one is a flip flop, so that we got qa plus. This is for b flip flop, so qb plus. Okay, so here we obtain, no, see the value, so we obtained this qb plus equal to. Okay, so just there is no difference between the first equation and the second equation, only the difference is in suffix we have a here, we in suffix we have a b, that is for a flip flop and that is for b flip flop. The transition equation is same for jk flip flop. Okay, suffix only change, but the value become jb equal to x dash. Okay, jb equal to x dash. See the jb value equal to x dash, right? So that so jb equal to x dash, and qb dash mean b dash plus kb dash equal to x xor a. Okay, x xor a. So kb dash mean x nor, so I put x nor here. Okay, a x nor x into qb equal to b. So final answer becomes x dash b dash plus, just I multiplied this b for a simple calculation. So a x b plus a dash x dash b. Okay, I'm going to substitute the values here. Okay, so I substitute the value. So qa is over. Okay, qa is over. Okay. Now we are going to substitute this value. Okay, so I'm going to substitute this value here. I'm going to substitute for this case. Okay, for this case. Okay, this case I'm going to substitute a equal to 0, a equal to 0, and b equal to 0, x equal to 0. I'm going to substitute and I'm going to put this value here. Okay, so value I'm going to substitute a equal to 0, b equal to 0, a equal to 0, and b equal to 0, and x equal to 0. X equal to 0. Okay, so what is x dash? X equal to 0 means x dash equal to 1. B dash equal to 1. So first term becomes 0, so answer should be 1. So you don't need to actually, we don't need to calculate this, because here we are going to, irrespective of the second case, second variable, just we will get a 1, because see, we'll get 1. A value is 0, so first portion of the second becomes 0, and b also 0, so second portion also becomes 0, right? So answer 1 plus 0 equal to 1. Okay, so I'm going to put 1 here. I'm going to put 1. Okay, so second case, a equal to 0, b equal to 0. The only value is x equal to 0. Sorry, x equal to 1. Right? Only change. Okay, substitute in the equation. So x dash. So x dash is, so x equal to 1, x dash equal to 0. Okay, x dash equal to 0, b dash equal to 1. Okay, b equal to 0 means b dash equal to 1 plus a into b. So this value becomes 0. First person a is 0, x is 1, b equal to 0, so that becomes 0. Second portion b value, I substitute b. So you don't need to calculate a dash x dash. Simply you put a b value. B value is 0 now. So I can put 0. Second portion also 0. So answer is 0 into 1 is 0 plus 0 equal to 0. So answer is 0. Okay, so we can put answer is here. Answer is 0. Okay, so next one is similarly you have to substitute all the values. Okay, I do two more values. A equal to 0. I'm going to substitute this value here. A equal to 0, b equal to 1, and x equal to 0. Okay, you substitute here x dash equal to 1. X equal to 0 means x dash equal to 1. B equal to 0, b equal to 1 means b dash equal to 0. So first portion becomes 0. And the second portion a into a value is 0, so I put 0. Second portion is a dash equal to 1. Okay, a dash equal to 1, x dash equal to 1, x equal to 0, so x dash equal to 1, and b value is 1. So the second portion, we are getting the second portion. Okay, so we can put in the bracket. So 1 into 0 is 0, 1 into 0 is 0, 0 plus 1 equal to 1. So the final answer equal to 1. So I can put the value here, a equal to 0, b equal to 1, x equal to 0 equal to 1. Okay, similarly just we have to substitute all the values. Okay, I do one more values. I do the last case. Okay, last case, a b equal to 1 1, x equal to 0 0. Okay, a equal to 1, b equal to 1, and x equal to 0. Substitute this value. X dash mean 1, b dash mean 0, plus a value, and here the x value comes, so x equal to 0, so x first value is 0, and b value is 1, a dash equal to 0, so a dash becomes 0. Okay, so second portion becomes 0, so answer is 0. Okay, for this case answer is 0. Okay, and next case, a equal to 1, b equal to 1, x equal to 1. Okay, all are 1 for this case. Okay, I'm going to write what is the value for here, because here x equal to a equal to 1, b value is the second variable, so b equal to 1, and x value is 1, because I'm going to calculate here. Okay, I'm going to calculate the value here, so x equal to 1. Okay, so this value is substitute in this equation, so we'll get x dash becomes 0, so first portion becomes 0. Okay, so irrespective of the second variable, and a x b all are 1, so I put 1, and a dash means 0, so second person becomes 0, so we'll get output as 0 plus 1 plus 0 equal to 1, therefore 0 plus 1 equal to 1, so I will get 1, so answer I get 1. Okay, similarly I have filled these values. Okay, qb values. See, first case 1 0, last case is 0 1, and second case, and this all we got 1 0 and 1 0. So I have substituted these values in this equation, and I got these values. Okay, this is the second step. Okay, what is the first step? We have to determine the flip-flop equation and output equation, and we have to obtain the transition equation. Since we are using two flip-flop, I use suffix A and B. Okay, so A, this is for A, and this is for B, and I substitute the values, input values, and I get the final equation. And final equation, I, I substitute the A equal to 0, the corresponding values. Okay, A equal to 0, B equal to 0, X equal to 0 means this value. Similarly, just I have filled all the boxes. Okay, the next step is plot the transition table. So this is the present state. Okay, present state, since we are using two flip-flops. Okay, so 0 0 0 1 1. The two flip-flop, so two states means, so we have four combinations. So I have written the four combinations: 0 0 0 1 1 0 and 1 1. And the next case, in the next case, x equal to 0 and x equal to 1. Okay, so x equal to 0. So a next state means a plus b plus. Okay, that is the next state. So next case, x equal to 0, what is the next state? When x equal to 1, what is the next case? We are going to calculate this. So, so when x equal to 0, see the table, x equal to 0, this table for QB, this table for QB, 1110 is QB, 1110 is QB. So QB means, QB plus means B plus, so 1110. Okay, so this value, okay, I have calculated these values. This is the QB dash. This is QB plus. This A plus equal to QA plus. Okay. So simply I have taken A, this value is B plus value. When x equal to 0, see the table, x equal to 0, what is the B? So x equal to 0, what is B? X equal to this is the case. X equal to 0, 1110. Okay, so 1110 I put. Here, when x equal to 0, the values are 0 110. 0 110. So I have taken this value. Just I have replaced this value. Okay, when x equal to 0, what is A flip flop condition? B flip flop x equal to 0, what is that? Just I have written this. Okay, next state of when x equal to 0, this. When x equal to 1, when x equal to 1, what is A? 0 111. So 0 111. 0 111. Here, this is for A flip flop. For B flip flop, what is x equal to 1? 0001. So 0001. Okay. A XOR B means, A XOR B means just you have to do A value and B value both are XOR. So 0 XOR 0 means we get 0. 0 XOR 1. Okay, just you have to put like this. So answer we get 1. Here also 1 XOR 1 XOR 0. So two different value means in XOR gate we get output 1. Same value means we get output 0. Okay, 1 XOR 1 is equal to 0. Okay, so 0 110. So this is the output. Okay, this is the output I have written here. So next case is you have to draw, we are going to convert A equal to 0 0, B equal to 0 1. We are going to convert the states. A equal to 0 0, 0 1 means B, and 1 0 means C, and D 1 1 means D. Like that we are going to convert. Okay. So this A equal to, so here 0 0. Let me, okay, so I'm going to convert this 0 0, I put A. This 0 1 means I put B. 1 0 means I put C. 1 1 means I put D. Okay, I put D. So 0 1 means here I 0 1 means I put B. 1 1 means I put D. Okay, small d. 1 1 means here also I put D. 1 0 0 means I put A. Okay. Here also I put 0 0 means A. 1 0 means C. 1 0 means here also C, and this is D. Okay. So next step I'm going to convert. I'm going to convert this 0 A, substitute A equal to 0 0. 0 1 means B. 1 0 means C. Wherever you find in the next state and present state, I convert. Okay, I have converted like this. Okay, whatever we have got this here, I converted like this. The answer is, and this table becomes like this. Okay, and next step is next step is okay. Next step, I'm going to draw the state diagram. I'm going to draw the state diagram. The state A to B, it goes when x equal to 0. Okay, at the time output is 0. Okay, you see the diagram. It goes A to B when x equal to 0. So A to B x equal to 0. So this is the input. This 0 is the input. Where is output? For A, output is defined as A by 0. For B, output is defined as B by 0. Sorry, B by 1. B by 1, because here we have 1. Here also C also output is 1. This is the important thing you have to identify for melee machine and more machine. In case of more machine, we will put the output in the circle itself, whereas in case of a melee machine, we will put a circle. The output will be mentioned like this, mentioned like for example, if A to B means this is A state, this is B state, means it goes A to B means we put like this. What is the input? Input is 1 and output also 1, like this. B to A means, suppose for example, just I am drawing this. Okay, so B to A means 0 by 0. So the numerator is input, denominator is output. This is for melee. This is for melee. So for the melee machine will get like, we will put the output in divided by the uh, input. Okay, whereas in more machine, we will put the output in the state itself. So I have put in the state itself A by 0, B by 1, C by 1, and D by 0. So this is the case. Okay, so A to B means x equal to 0. A to B means x equal to, input is 0, and A to A means x equal to 1. So A to A, so the state is made in the same state, right? The A state is made in the same state when x equal to 1. So input is 1. And next case, first is over, right? Okay, A to B and A to A is over. A to A x equal to 1, A to B x equal to 0. So it's over. So B to D is in x equal to 0. So B to D. Okay, see B to D. This diagram, B to D. Okay, B to D, it goes. B to D x equal to 0, B to D x equal to 0, and B to C, B to B to C x equal to 1. Okay, so B, it goes to B to C when x equal to 1. Output is mentioned in the circle itself. And C to D input is 0, and C to C in input is 1. See, C to C is 1, C to C is 1, and C to D. Okay, this here arrow is missing, but you put a arrow. Okay, C to D. C to D is 0. So here 0. Okay, input is 0. And D to A, D to A D to A is 0. So D to A is 0. Input is 0. Input is 0. And the D to D is 1. D to D is 1. Okay. This is state diagram. So you have to know that we come to the end of the slide. Okay. So this is in general, the more block diagram will be like this: input state, the combination circuit, and flip flop. These two portions. Okay. Okay. These two portions, this combination circuit and flip flop, this combines, we call this a sequence circuit, right? Sequence circuit, we will get a flip flop output will be feedback, is a given as feedback. Okay. So this is the general term of a sequence circuit. Okay, this is sequence circuit. Sequence means we have a sequence circuit. Okay. And in addition with, we'll have one more flip flop in more state. Okay, we'll have a more state. We will have a more state. One more flip flop is there. Okay. So this is the conditions of more block diagram. Okay. So in a given problem, we have the combination circuit. See the diagram. We have the combination circuit. So this is the combination circuit 0. This is a second. This is a flip flop circuit. This is a flip flop circuit. This third portion also combination circuit. Okay. So here, see the output in this circuit. In the more model, we'll have the output is depend only on the flip flop state. Okay, next state. Okay, present state. Next state. Present state. So that we are saying that in more machine output depends only on the present state. Okay, flip flop states. Okay, not on the input. Not on the input. Okay, so this is a observation in this problems. This you should know that how we got the more machine works. Okay, the output depends only on the flip flop case. See, qa, what is f equal to a x or b, right? So this is a and this is a b. So both the states, so a output depends only the state of the flip flops. That is the main concept in this problem. So in case of melee machine, the output will be depend on the input also. This is the final step. Okay, so I hope you could understand this problem. Okay, so what is the first step? So f equal to a xor b and ja ka, this is the first step. We are obtaining the flip flop input and output. And second case, transition equation, we substitute a and for b flip flops, and we put this table and we convert the transition table, and we have to draw the state table, and this is state diagram. I hope understand this problem, and we'll see you in the next class. Okay, thank you.